Hi, and in this video, we'll be performing some operations on graphs. So graph is a very popular data structure which we have covered before. In the last video of the same playlist on the same channel, you'll find a video in which I have introduced you to graphs, and also we understood the topics of adjacent matrix and adjacent list. We also wrote code for it, and for that we actually created a very simple graph which had operations like add, edge, add vertex. So we'll be performing the same operations, but yeah, today I'll make you understand more efficiently, and yeah, you'll see that yeah, what's the difference from yesterday. So actually yesterday the was more focused on the adjacent list and adjacent matrix. So if you want to see that, I'll just show you on the okay, just visit this channel, Geeks for Geeks practice channel, and here you will find that in the playlist section we have the playlist named as data structure using JavaScript. Okay, so here everything is available, and here you can see that all the previous videos which are required for data structures topic is available. All kinds of data structures are available, and I think 2-3 more are remaining, then this playlist will be complete. So here you can see that we have actually covered the graphs topic, in which we have specifically focused on the adjacency matrix and adjacency list. So you'll get that, and I have explained what's the logic for that. Okay, so please watch that video, and then in this video I won't be covering the extreme basic of graph, but yeah, I'll be explaining you how are we adding edges, and how are we adding the vertex, and how can we actually delete those. Okay, so let's begin. So before moving on, in the live chat, you'll find the link of a course provided by Geeks for Geeks. So it's a course for you all. Okay, if you want to learn DSA in JavaScript, you can purchase this course. So in the description here, you can see that a description is mentioned here, and also the course content is mentioned here. Whatever they are going to teach, you will find this. Okay, so here you can see that yeah, we'll be starting with the introduction, then mathematics, then bit magic, then all kinds of data structures and algorithms which are needed for DSA. Okay, so by the way, if somebody has a doubt, yeah, DSA is different in JavaScript. No, it's same in every language. Either you learn DSA in C++ or in JavaScript. Like suppose if you are learning DSA in JavaScript, so in future you might find, yeah, language is definitely different from JavaScript and C++. If you try to learn it in C++, definitely the language will be different, but the logic will be exactly same. So either you can learn in any language you want. Okay, so yeah, it's a great course. You can buy this one, and it's specially for, I would say that if you want to choose an easy language, you can choose for JavaScript, or if you want to do more in web development field, then you need DSA knowledge also. Okay, so you can go for this course. All right, so now we can continue, and here what we'll do is I'll be starting with the code part. Okay, so let's begin, and I'll say that yeah, this is suppose lecture 7. Okay, fine, and I'll just open it with VS Code. Fine. So all the installation part has been taught before. Only some basic installation of VS Code and Node.js is required, then you are good to go. So here I'll be creating a file named as script1.js. Inside this we'll be uh, creating a graph in which we can add a vertex and edge, and then also we can delete things. Okay, so let's begin. So first of all, we need to initialize a graph. So for initializing a graph, what can we do is we can simply add things. Okay. Yeah, fine. So for that, first of all, let's create a class named as graph. Okay, class named as graph. So we have created a class. Inside this, first of all, we would need a constructor. So initially in any constructor, you would simply say that the constructor will be having no, like this graph won't be having any vertices. Okay, so I would say that this dot vertices equals, and let's keep it like that. Okay, so vertices can be, there can be any number of vertices, and any number of vertices can have any number of adjacent edges. Okay, so I have explained graph before, so you can watch my last video to get a better understanding how are we creating this graph class. Okay, so now we would say that let's add a vertex. So for adding a vertex inside this, I would simply say that I need a vertex value. Suppose somebody wants to add a vertex 2. So obviously 2 will come here. Okay, so inside this you can say that if this is not already present, like if previously 2 you have entered 2, so no new vertex will be added. Okay, because a graph will have, in this case I'll be assuming that we have unique vertices. Okay, unique vertices. So fine, so I would say that if it's not available, already not available in my old vertex. Okay, I would just say that if it's not available before, like suppose if I gave 2 here, I would say that if 2 is not available, then we would add things. Okay, and let's do one thing. Um, Here we have created, I think. So yeah, in this you can see that we have it. Okay, so what I would do is again, yeah, here you can see we have created a similar one, and we have actually created a Okay, we have actually created this using, you can see that we have created this using adjacent list and some things like that. Okay, but yeah, today I'll be following a different approach, just a normal approach, not the adjacent list or adjacent matrix, which we have followed before. Okay, so this approach will be different from yesterday. You can see that yesterday's approach is different and today's approach is different. Okay, so you can go for both any of them, but yeah, today I'll be using a simple approach to create a graph, just a simple approach. Okay, so we have initially made it empty. Then I would say that if it contains 2 or any other number which I have given it as a vertex, so this condition won't be followed. If the vertex wasn't present before, so here I would simply say that yeah, just add the vertex, and this vertex will contain an array inside that. That simply means like 2 will be added. Okay, suppose 2 will be added, and then with that 2, an empty array will be added. Okay, suppose you want to add a vertex 3, so 3 will be added, and with that an empty array will be added. It's like that. Okay, suppose if I want to again add 2, it won't be possible. It won't be possible because it's not following this condition. Okay, so I won't be able to again add 2. It will skip that. It will skip that because I already have 2. Okay, so it's like that. So here you can see that that's how you can add a vertex. Then you can add an edge also. Edge simply means, like if I talk about add edge, and I need to specify the vertex 1 and vertex 2. Suppose I want to create an edge between 2 and 3. What would happen is I would say that 2 is actually connected to 3 and 3 is connected to 2. It's like that. If I talk about undirected graph, that means you don't have any specific direction, you can go in any direction. That means from 2 to 3 and 3 to 2. Okay, if I talk about that, if I only can go from 2 to 3, so 2 won't be added here. Okay, 2 won't be added here. Okay, and similarly if I only can go from 3 to 2, so 3 won't be added here. It's like that. Okay, so we'll follow this approach inside this actually. Yeah, inside this. So right now we are just assuming that we can go in any of the directions, so you can either go from 2 to 3 or 3 to 2. It's like that. Okay, so here you can say that this if this 3 isn't already connected to 2, like if it's not connected to 2, then you will be connecting it to 2, right? So here I would just say that if this specific vertex, that means if v1, if vertex v1, okay, v1, let's say v1 is 2, is isn't already connected, includes, and inside this you would say if it isn't already connected to 3, then you would connect it to 3, right? Then you would connect it to 3. So it's like you would connect it to 3. That means you are simply pushing 3 here. If it was previously connected to 3, then why would you add 3 again? The logic says that. Okay, so it's like that. So if it's already connected to 3, this condition won't be followed. And similarly, if you are talking about the opposite direction, you would simply switch v1 to v2. Okay, so similarly you can say that if v1 does not have an edge v2, okay, no, it simply means that if v1 is not having an edge v2, then this will be followed. If v2 is not having an edge v1, then this will be followed. Okay, Obviously both will be followed because it's in both direction. That means if 2 is not connected to 3, 2 will be connected to 3. If 3 is not connected to 2, 3 will be connected to 2. It's like that, okay, in both the directions. So I would simply say that, yeah, in this v2 I would simply push 2. Okay, it's like that. In this v2 I would simply push 2, and similarly you can add more edges like 4, 5, 6. So it simply means that 3 is connected to 2, 3 is connected to 4, 3 is connected to 5, 3 is connected to 6. It's like that. Okay, so that's how you can add edges. So here you can see that this condition will be satisfied, and then we are good to go. So this is one thing. And one more thing, if suppose I add some edge 21, okay, but 21 doesn't exist, then what must happen? So you can simply say that if any of the edges, either v1 or v2, doesn't exist, okay, then you would simply say that vertex doesn't exist. You are trying to achieve, you are trying to join one vertex to other vertex, and any of the vertex doesn't exist, then this is not possible, right? So I would simply say that if v1 is not present, okay, or v2 is not present, okay, that means in our array of vertices we are simply adding all the vertices which are available, and since v1 like 21 is not available, so you would simply say, yeah, you can't perform this edge operation because no edge can be created because one vertex is not available, right? So here you would simply say, you can actually throw an error here. So here you would say throw new error, vertex not found. It's like that. Okay, so you'd simply say that, yeah, vertex is not available if you're trying to achieve some different vertex which is not available. Okay, so this is a simple procedure and you can add things like that. So now I think we can actually try to do things. What I would do is I'll just create a graph, and I would add a vertex. Suppose I'll just add a here. Okay, I'll add a here, and you can actually add any value inside the vertex, not only number. You can add any anything you like. Okay, so a, b, and let's add c. Okay, and what I'll do is I'll just add an edge between a and b. Okay, add an edge between A and B. That means A will be connected to B, B will be connected to A. It's like that. Okay, so again, you can say that A is connected to C and C is connected to A again. And then I'll just say console.log vertices. Let's try to get that so that we'll get the vertices and what they are connected to. Okay, so I'll simply say that run this. So you can see APH is not defined. Why is this happening? APH dot vertices. Again, I think we need to run this again. Yeah, now it's fine. So here you can see that A is connected to B and A is connected to C. So this is the first vertex and its edges. Clearly you can see that B is connected to only A, C is connected to only A. So it's like that. Okay, so you can see that we have successfully added a vertex and we have added some more vertices and we have added some edges. Okay, that means A is connected to B, B is connected to A is connected to C, C is connected to A. Okay, so I hope you understood this, and that's how you can simply add an edge and a vertex. Fine. So now what we can do is, since we have added a vertex and an edge, now let's know that how can we actually delete an edge. Okay, suppose I want to delete an edge, that means I don't want to delete, I don't want any edge between B and A. How can I do that? Okay, how can I do that? Obviously you are passing things like that, but obviously like if you're working on a very big company, or you are having a very big database which is connected in graph format, then you won't be writing things like that every time. Okay, you'll be getting data from somewhere, so it's very difficult to write things like that, and data is already written. Okay, previous data is already written, so how you can delete that data? Okay, delete any specific edge from that graph. So for that we'll be creating a function here. Okay, so I would just say that I want to delete an edge. Okay, so let's do one thing. Let's start by deleting a vertex. Suppose I want to delete a vertex A. So let's do that. Okay, so here I would simply say that delete vertex, and you want to delete any vertex. What you would do that if that vertex doesn't exist. Okay, so here you would simply say, I'll just do one thing. I'll just copy this first one. And here you can just say that if that vertex doesn't exist, then you would simply say vertex not found. Okay, vertex not found. So first we'll be calling a for loop. Okay, why am I calling a for loop? Because this vertex might be having some edges, right? So I will delete the edges also. Okay, so I would say that const adjacent vertex of this dot vertices. That means adjacent vertex is simply like if A is connected to B, A is connected to C. That so it simply means that if A is connected to B and A is connected to C, so adjacent vertices of A are B and C. Okay, so it's simply targeting B and C. Okay, it's simply targeting B and C. And I'm taking a case where we have A and it's connected to B and C. Okay, so what I'm trying to do is, first of all, I'll check that if A exists or not. A exists, right? Then I would check that A is connected to how many adjacent vertices. I'll be calling each of them one by one. That means I'll be calling this B and I would remove the connection from A. Okay, I remove B's connection from A. That simply means that if I draw this is actually the figure. Okay, if A is connected to B and A is connected to C, that simply means B is also connected to A and C is also connected to A, right? So first of all, I need to delete this connection. I want to delete this connection. Then I would delete this whole. It's like that. Okay. If initially I would delete this, then what would happen is you are going from B to A, but A doesn't exist. So how is this happening? So first of all, you need to delete these two. Then you can delete this. Okay. So it's that way. All right. So now for that, what we can simply do is const adjacent vertex. So it simply means that I am getting these values, whatever are the adjacent vertices of this B. Okay, suppose if I take this loop, this first adjacent vertex is what? B. The second time loop runs, the adjacent vertex is C. Okay, so right now, first of all, the case is B. And suppose it had a few more things like C and D and E. It simply means that B is connected to A, B is connected to C, B is connected to D, and B is connected to E. It's like that. Okay. Now what I want to do is I want to simply remove this A. That means first of all, I have my whole vertex edges. That means I have A, C, D. From this, I want to simply remove this A. That's it. That's what I want to do. So for that, what you can do is simply splice that specific index. So for that, I want to find the index of A. Index of A. So I would say index equals adjacent vertex edges dot index of our vertex. That means this A. I want to find the index of A. Okay, I hope you are getting this. So we simply found the index of A. Index of A is actually 0. Okay, so what I would do is I would simply splice off that index and one value. That means from 0th index, I want to splice one value. From 0th index, I want to splice one value. That means this A will be removed like this. Okay, it's like that. Okay, so I hope you are getting this, and that's how you can actually remove any edge. First of all, you are removing adjacent edges, like you are removing adjacent edges. You removed A from here, and similarly the next time loop runs for this C, this A will be removed. Okay, and you might have some other things also. You don't worry about that. Like this, you had CDE, you might have some other vertices also. You don't need to worry about that. You are actually removing A from here, you are actually removing A from here. Then at last you will be removing this, you will be removing this, completely deleting this. Okay, so once this loop has been completed, you can simply say that I want to delete operation can be called directly, and this would simply delete the vertex. That's it, delete the vertex. Okay, so that's how it actually works, and that's how you can delete this vertex. You can delete that specific value from that array. Okay, you can delete the A. Okay, I hope you got this, and instead of this delete, you could have also directly spliced also, it would work. And now what I have done is I've simply said that first of all I removed A from here, right? Then I removed this completely. So now you can see your graph doesn't contain A anymore, right? Your graph doesn't contain A anymore. So it's like that. So we have deleted a vertex like that. Okay, so what I'll do is if I want to suppose add an edge between B and C, And now if I delete a vertex, okay, so before that and after that we'll see things. Okay, so what I'll do is, first of all, we'll see things before deleting a, then after deleting a. Okay, so I hope it is fine, and let's run this. So here you can see that before deleting a, we had connection from A to B, A to C, B to A, B to C, C to A, C to B. Okay, it's like that. But after deleting A, we only have connection between B to C and C to B. Okay, so that's how delete vertex works. Okay, that's how delete vertex works. All right, so similarly, we have another operation that is known as delete edge. Okay, so you again can delete the edge in a similar way. So let's do that. And I think that this is the only operation which remains in the graph data structure from my side. So what I'll do is, now we'll be deleting a edge. So I'll just say that for deleting a edge, we actually need to know one thing. Like suppose I would say that I want to delete, and suppose v1 is suppose a. Okay, let's say v1 is a, and v2 is b. Okay, and let's say that a is connected to b and c, and b is connected to A and C. It's like that. So what I want to do is, I want to remove edge between A and B. That means I want to remove B from here, and I want to remove A from here. Okay. I hope you are getting this. Okay, so that's how you can actually remove or delete any edge. Okay, so let's do that. So here I would simply say that, first of all, I would say that, yeah, if this vertex doesn't exist, both of these doesn't vertex exist, that means I want to remove an edge from A to 29. 29 doesn't exist. How can I delete a vertex 29? I mean, how can I delete an edge between A and 29 if 29 doesn't exist? So it's like that. So I have simply checked that if any of the vertex doesn't exist, simply return vertex not found. Okay, vertex not found. And then after this, you would say that, first of all, I want to find the index of this B. First of all, I want to find the index of this B. So I would say that const. First of all, you'll say, yeah, you'll get all the edges. That means you are getting this B and C. Okay. And similarly, you'll say that V2 edges are actually A and C. Fine. Then you would say that it's giving me B and C, and it's giving me A and C. It's like that. Okay. So then you would say that I want to find the index of this B. Okay. So I would say that const V1 index. Okay. So I simply want to find the index of v1. Let's write this as v2 index. That simply means that I want to find this v2's index, in v1 edges. Fine. So I would simply say v1 edges, and I want to find the index of v2. That means I want to find the index of b. B is actually at 0th position, so it will simply return 0. It's like that. And similarly, you would say that v1 index, that means I want to find v1. I want to find v1 in actually this v2 edges. Okay, in this v2 edges. So I am trying to find a here. So I would simply say that, yeah, a is available, so I would simply return its index, whatever is the index. Okay, so it will simply return 0 and simply return this. Okay, it can be in different order also, not only in this order. You can either write it this way also. It means the same. Okay, if it's this way, then it would have returned this. Okay, it would have returned this. So it's like that. Okay, so for your more understanding, I would simply change the order. So you can see that in this case, it's returning 1 and it's returning 0. Okay, I hope you're getting this. Now what I want to do is, I want to remove the things. So for that, I would simply say that I would simply remove that index, okay, from my v1 edges. And similarly, I would remove the index of v1 from my v2 edges. So it's like that. So I've removed this 0 index. That means I've simply removed this b. If I want to remove this one index, I'd simply remove this. Okay, so what happened is, I have removed association of A to B and B to A. It's like that. Okay, so I have removed association from A to B. That means this index is removed. Okay, and similarly, this index is removed. Okay, so it's like that. All right, so that's how you can do things. And then after this you have removed things, and now what I want to do is I have actually removed it here. Okay, so one more thing, that if it's not there, okay, if one vertex is connected to other but other is not connected to one, then what happened? So actually this would be -1 if it doesn't contain v2. If it doesn't contain v2, it would simply return -1. So it's simply there that if it's returning -1, it simply means that it's not there. So okay, so in that case things will be avoided. But if it's there, then I would say that if it's not -1, that means if it's 0 1 2 3 4 any index, but if it's not -1, that means the return index by this is not -1, then you can simply remove that index. Okay, then you can say that yeah, it's there, so I can simply remove that edge from that specific index. Okay, so that's like that. Okay, so you can see that yeah, same thing, but you have simply said that if the index is not available, that means that specific vertex is not available in other, then it would simply return -1. So why would I perform an operation in -1? That's why I've simply returned it. Okay, so it's like that. So now let's test this, and now I'll be removing an edge. Okay, so let's see. So right now if I just write it this way, I'm not deleting it, and if I just try to run this, so here you would see that yeah, I have an edge from A to B, A to C, B to A, B to C, C to A, C to B. Okay, now I am going to delete an edge from A to B. So for deleting an edge from A to B, this B will be removed, okay, and this A will be removed. Okay, that's it. So now let's try to do this. So I would simply say I want to delete an edge from A to B. Fine. So now what would happen is if I try to get the vertices, what would happen? Simply association of A will be removed and B will be removed from each other. So you can see now what has happened is B is removed from the first vertex and A is removed from the second one. Okay, so here you can see things are fine and the logic is complete here. Okay, obviously the graph can't be actually displayed in the graph format, but you can actually use this logic in your front end part of code, and then you can display it in graph interface, whatever you want. But yeah, in backend things will be happening like this only. Okay, so you can see that yeah, it's working fine. You can see that I've removed association from A to B and B to A. Okay, so that's how you can remove any edge. So right now we have performed three operations which are the most important ones. We have actually first of all created a very basic graph with an empty set of vertices. Then what we have done is we have simply added vertex. Okay, we have added edges, then we have deleted vertex, we have deleted edges. Okay, so that's how we can perform these operations. So these were some basic operations which you can perform in any graph, and these are the most important ones. And I think nobody has covered this on YouTube till now, so like on specifically JavaScript. So this video will be very helpful if you are performing anything on graph, and if you want to display it in a beautiful manner in front end part, then definitely you can connect this JavaScript. You can write the same code in any backend, or you can write it in plain JavaScript, then you can show it in your HTML page and in a more beautiful format. Okay, so things are like that, and I hope you understood that. If you have any doubts, you can ask me in the live chat. All right. Hmm. So request to make live stream for operations on string and operations on spiral matrix. Okay, spiral matrix. All right. So what we would do is we would be building a specific playlist for strings, because string is a vast topic in JavaScript. If I talk about string, and I have an experience of around 1 year. I would say that yeah, in advanced JavaScript, but still I would say that yeah, string is an important concept and it's difficult sometimes. So definitely I'll be bringing a live stream on the operations which are required for string, also for the spiral matrix. And Personally, I haven't performed spiral matrix operations on JavaScript, so I'll be doing some more research about that. But definitely, we'll be bringing a live stream on string. Maybe on the same playlist, you'll find the string concept, because since you have requested, so I will try to add the string video on the same playlist. Okay. So you can actually find the playlist on the channel Geeks for Geeks practice channel, and if you click the channel, you'll find the videos here in the live section or in the playlist section. You'll find the data structure using JavaScript. You can visit this playlist. Inside this, you'll find all the previous videos and all the upcoming videos on data structures using JavaScript. And also in future, we would try to bring some more tutorials like that, and definitely algorithms part is also remaining. So I think we'll be building a specific playlist for that. So we'll see that. But yeah, that will be introduced in this channel definitely. And also the string topic which somebody has mentioned in the live chat. So before ending this video, actually in the live chat or in the description, if you want to learn DSA in JavaScript from beginner level to advanced, you can actually visit that link. This is a paid course, and it's you can say that all things are actually covered here. You can see that in the content you will find introduction, mathematics, bit magic, arrays, recursion, searching, sorting. So all the algorithms and the data structures are available here. So it's a complete course from beginners to advanced. So if you want something like that, you can check out this one. A lot of people have doubts in their mind that if you are learning DSA in JavaScript, then it's not worth it. Like it's very easy and it's like that. So it's not like that. Like some people want to learn things easily, and some people want to learn things in the difficult way. You can choose either the way, it's not any compulsion. But yeah, if you want to choose an easy language for your beginner journey, you can choose JavaScript with DSA. And personally, I have felt that yeah, it's easier than C++ or any other language. But yeah, personally in C++ there is some better implementation of DSA logics and the better usage in memory and like that. But in JavaScript, you can have a good understanding of these topics very easily because the code is too easy. Okay, I have felt that the code is too easy, and you can simply write any algorithm and any data structure in just a few lines. You don't need some complex symbols or like that. So it's very easy in JavaScript. So you can go with this course. This is a very great course. And if you are trying to become a web developer or an app developer, you might be encountering JavaScript operations, so you can check out this one. Alright, so I hope you understood this, and in this video we have covered the basic operations on graphs. So in the next video we'll be starting with stack and queue, and then we'll be having some more videos on the operation of stack and queues. After this we have linked list. Okay, we haven't covered that, so we'll be covering linked list also. Alright, so that's it for this video. If you have any doubts, you can ask me on the live chat, and in any of my videos you can ask any of your doubts regarding any of the technologies in web development or DSA also. So that's it. So all right, so that's it for today. I will see you in the next one. Till then, see you, have a good day. Bye bye.